We are doing the last part of Newton's laws, or last law, which is Newton's third law. I hope you watched the first law and the second law. Now we are doing the last law. You see that guy on the screen there, he's reminding you of something. So please do not ignore him. Just do what he's showing you. And I'm reminding you to do not forget to share and comment. These are the laws that we've discussed so far. Newton's first law, Newton's second law. So Newton's first law states that a body will remain in a state of rest or uniform velocity unless it is acted upon by an unbalanced force. Then we did Newton's second law that states that when a net force acts on an object, the object will accelerate in the direction of the net force at an acceleration directly proportional to the net force and inversely proportional to the net force. And I gave you the simplest way of defining Newton's second law. You define it in this way, that the resultant force on an object is equal to the rate of change in momentum. Now we are doing Newton's third law. The most important thing for you to know about Newton's third law, let me just say this about Newton's second law, that Newton's second law is applicable in one object where there are several or one or more forces acting on it. But now in Newton's third law, for it to result or for it to exist, or it is applicable when two objects interact with each other. So Newton's second law is applicable when one object experiences several forces acting on it. But Newton's third law is applicable when two objects interact with each other. I don't know if that's clear to you. But for Newton's third law to result or to exist, there must be two objects interacting. So that's very important for you to know. So Newton's third law states in this way: when one body exerts a force on a second body, the second body exerts a force of equal magnitude in the opposite direction on the first body. So what does this mean? Let me say I have body A and also body B. So body A will exert a force on body B. Now body B will also exert an equal force on body A, but in opposite direction. For an example, let me say you place your laptop on top of the table. Now the laptop is the first board, or it's body A. Let me just say it's the first board. Then the table now becomes the second board. Now the laptop exerts a downward force on the table, which is the gravitational force. Also, the table exerts an equal upward force on the laptop, which is the normal force. I don't know if this is understood, but it's very important for you to know that when the laptop is placed on the table, it is the body A, or it is object A, and the table is object B. So the laptop will exert a force or a downward force on the table, which is the gravitational force. And also the table will exert an upward or an equal upward force on the book, which is the normal force. For an example, you as a person, you are seated right now. Now as you are seated, you are the first body, and the chair or wherever you are seated, that place is the second body. Now you are exerting a force on that chair, the downward force, and the chair is also exerting a force on you, the upward force, which is normal force, but in opposite direction. Let me make another example of Newton's third law. For an example, do you see a trampoline? when you jump on it, you are the first body and the trampoline is the second body. So Newton's third law, there is a possibility for it to do what to results. So you are the first body jumping on it. Actually, when you jump on it, you are applying a force, a downward force, which is the gravitational force. So as the trampoline now, you jumped on it, it will push you up. So you see, it also exerts an upward force to you as the object A, but now in opposite direction. So it is very important for you to understand that Newton's third law is applicable when two objects interact. There's another way of defining Newton's third law. You just say that for every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction. It's still the same thing if you can just listen to it. Yeah, so we won't discuss much about Newton's third law. Then in Newton's third law we have something known as Newton's law of universal gravitation. This is what we're going to discuss right now. This is how we state Newton's law of universal gravitation, that every body in the universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. So it is very important for you to know how to define Newton's law of universal gravitation. So actually here we are talking about the gravitational force, and gravitational force has the following properties: that it is an attractive force and it is also a non-contact force. So it exists between two objects with mass in the universe. So you must know how to define it in that manner that I've defined it. This is the formula for Newton's law of universal gravitation, where Fg it is the gravitational pull measured in Newton, G it is the universal gravitational constant of 6.67 times 10 to the power negative 11. Then m1 and m2, those are masses measured in kilograms. Then r it is the distance measured in meters. So if you are given centimeters, multiply by 10 to the power negative 2. If you are given millimeters, multiply by 10 to the power negative 3 to get 2 meters. These are conversions. Okay, and the first thing here, it is that the SI unit SI unit, not units. So the SI unit for mass is kilograms, kg. Now you might be given grams, so in order for you to convert grams to kilograms, what you must do, it is that you multiply by 10 to the power negative 3 in order for you to get to kg. So for an example, gram multiplied by 10 to the power negative 3 to get kg. So it is very important for you to know the SI unit for mass and also for distance. For an example, we have 2 grams. Now they say convert it to kilogram, because we are not dealing with grams but with kg. So you multiply by 10 to the power negative 3 to get 0.002 kg. So this is how we convert grams to kg. Make sure that you use correct SI units. The mass of the moon is 7.35 times 10 to the power 22 kg, and the mass of the earth is 6 times 10 to the power 24 kg. The distance between their centers is 3.84 times 10 to the power 9. Now they say calculate the gravitational force between the moon and the earth. So what you need to check now, you are given mass 1 here, which is mass of the moon, and the mass of the earth, and you are also given the distance. Now they say calculate the gravitational force or the gravitational pull. Remember, a force it pulls or pushes. So F equal to gm1 m2 over r squared. Knowing that g, it is 6.67 times 10 to the power negative 11. Now you put a bracket for substitution. Now mass 1, you are given the mass of the moon, which is 7.35 times 10 to the power 22. All right, now the other mass, which is the mass of the earth, which is 6 times 10 to the power 24 kg. We are happy because they are in kg. There's no need for us to do what to convert. All right, now the distance that we are given between their centers, it is 3.84 times 10 to the power 9. Now it is in meters. We are also happy because distance is measured in meters. Don't forget to put the exponent 2 there. Now use your calculator, you get 1.99 times 10 to the power 18 Newton. So let's check the second question, or number 2. Name Newton's law that you applied in question 1.1, which is Newton's law of universal gravitation. Yes, Newton's law of universal gravitation. So for an example, let me say in 1.1 they say define Newton's law of universal gravitation. Then in 1.2 they tell you to calculate. You must know that you must use the formula for Newton's law of universal gravitation to calculate that force. So here it's 1.1. I don't know if you understood this. So in this formula you may be asked to calculate the force, the mass, or either the distance. Now you are given the earth and its mass, and that person there, your uncle, with the mass of 170 kg. Then they say the radius of the earth is 6.38 times 10 to the power 6 meters. Determine the force that the earth exerts on the man, on your uncle. So you are given your masses there in their SI units. So F equal to gm1 m2 over r squared. Therefore you know the value of g, which is 6 times 10 to the power negative 11. Put your brackets for substitution. Then mass 1, mass of the earth, and mass 2, which is the mass of your uncle, mass of the man, and you divide everything by what? By the distance. Don't forget to put a squared. I don't know if you get. So the radius of the earth is 6.38 times 10 to the power 6. That's our distance. Now the mass of the earth, it is 5.98 times 10 to the power 24. Then the mass of your uncle, it is 170 kg. So it's a lot. And the radius of the earth is 6.38 times 10 to the power 6 meters. We are happy because this measured in meters. So 6.38 times 10 to the power 6. Then use your calculator, punch your calculator, you will get 1665.84 Newton. They say determine the force that the earth exerts on the man. you got that force, right? Now they say determine the force that the earth exerts on the man. Now the next question might be like, what is the magnitude of the force that the man exerts on the earth? It will be the same answer but in opposite direction. Now they'll say explain why or which laws of motion is applicable or support what you have said. It will be Newton's third law, then you explain or you define Newton's third law. I don't know if you understand that, but it's very important. You will come across those types of questions. So when they ask you the magnitude of the force that the man exerts on the earth, it will be the same force but in opposite direction. You were asked to calculate the force that the earth exerts on the man. Now they will say, what is the magnitude of the force that the man exerts on the earth? It will be the same force that you got in 1.1, but it will be in opposite direction. You may be asked to differentiate between weight and mass. So weight, it is the gravitational force exerted on an object by the earth, where mass, it is the amount of matter in a body. So you must know how to differentiate between the two. It is usually 2 marks. So this is the last part of our lesson, Newton's third law. So make sure that you know how to define Newton's third law. Make sure you know how to define Newton's laws of universal gravitation, and try to attempt question papers to make sure that you understood from the first law to the third law, which is what we're doing right now. And please do not forget to subscribe, like and share. All right, thank you guys a lot. Make sure that you know everything about Newton's laws and try to attempt question papers, because when you attempt question papers you also learn new things there. So good luck.